All right, listen up. Welcome to this explainer. Today, we are taking the Cambridge Computer Science syllabus, specifically database terminology, and we are mapping it out like a master architect. I want you to think about the title for a second, The Street Artist. A brilliant street artist makes these incredibly bold, eye-catching marks, right? But here's the secret. Those bold strokes of creativity are absolutely nothing without a rock-solid underlying structure. If the canvas is weak, the art crumbles. It's the exact same thing with your Cambridge exams. Whether you're building foundational skills in the 0417, 0478, 0983, 0984, or 2210 syllabuses, or you are pushing the absolute limits in the advanced 9618 A-level, it is not just about knowing a bunch of terms. It's about structure. It's about how you frame your knowledge. So today, we are giving you the ultimate strategy guide for making your mark and mastering primary, candidate, and secondary keys. So let's just address the elephant in the room. Here is the ultimate question. It's the one every single student asks me. What actually separates a B grade from an A-star grade in Computer Science 9618? Seriously, think about it. Is it just reading the textbook 10 more times? Is it making more flashcards? Absolutely not. Talk to any senior examiner, and they will tell you straight up that the difference almost always comes down to one absolutely crucial element: the precision of your database terminology. It is not about raw knowledge. Everybody knows what a database is at this level. It is about how accurately and systematically you deploy terms like primary key, candidate key, and secondary key. The top-scoring candidates, the ones who get those A stars, they don't just know what these words mean in a dictionary sense. They understand how these terms build actual causal relationships within a complex system. And more importantly, they use them on the exam paper to demonstrate deep analytical depth rather than just superficial breadth. Okay, here is our roadmap for today. We're going to hit the ground running with the database challenge, dive into defining database keys, map out the procedural framework, get hands-on with an interactive workshop, expose the top examiner pitfalls, and finally build your final system. Let's get into it. Section 1, the database challenge. Let's set the stage and look at the actual reality of these past papers. Now, you might be wondering why so many smart students drop marks. Well, when facing past paper questions, students completely abandon their analytical frameworks the second that clock starts ticking. They just panic. They forget that examiners are targeting very distinct cognitive domains: knowledge, application, and analysis. Let's look at two hypothetical students taking the exact same exam. On the left, we've got Alex. Now, Alex studied incredibly hard. Alex practically memorized the textbook. But look at this answer. It is completely overloaded with raw computer science facts, just a massive brain dump, but there is zero critical analysis. Alex failed to provide any logical, structured reasoning. The examiner is literally begging for analytical depth, and Alex just gave them a shallow puddle of facts. Then over on the right, we have Sam. We've all been Sam at some point. Sam felt that time pressure, totally panicked, rushed the execution, and completely missed the command word requirements. The question said evaluate, and Sam just described. Sam completely failed to extract the relevant data from the specific scenario given in the prompt. Both of these approaches absolutely bleed what we call method marks. Those are the points awarded for your process and for systematic analysis. Let me be clear, you do not want to be Alex, and you definitely don't want to be Sam. You want to be the student who structures their reasoning perfectly using a framework like PEAL: point, evidence, explanation, link. We'll get into that in a minute, but first, we need our building blocks. Section 2. Defining database keys. Time to lock down the theoretical architecture. Let's start with the absolute basics, but we're going to look at it through an examiner's eyes: the primary key. Simply put, a unique identifier for a specific record in a database table. But why does this actually matter? Why do they test this every single year? Because the primary key is the literal bedrock of a relational database. It's the anchor. It is what establishes the causal relationships required to make the entire system function. Without a unique identifier, you literally cannot reliably update, delete, or link records without causing a massive data anomaly. So when you write your exam answer, yes, you need to state this definition, but you also have to prove to the examiner that you understand its functional purpose. You have to explain how it maintains data integrity. That's how you get the points. Next up is the candidate key. This is defined as any attribute or set of attributes that can uniquely identify a record from which the primary key is actually chosen. Look, this is where examiners really start separating the grades. This is where they test your higher-order assessment objectives. They don't just want you to point out one unique field like a primary key. They want to see your algorithmic thinking in action. They want to see you evaluate the alternatives. Think of candidate keys like applicants interviewing for the job of primary key. If a table has a student ID, an email address, and a national insurance number, well, all three of those are candidate keys. But which one is best? Demonstrating to the examiner that you understand how to compare these options, evaluate the trade-offs, and make a justified recommendation, that is the exact analytical depth that pushes you over the A-star boundary. And finally, we have the secondary key. This is an attribute or combination of attributes used strictly for data retrieval and sorting purposes, and crucially, it is not necessarily unique. This is a massive opportunity for you right here. This is a brilliant chance to make those cross-topic connections that examiners absolutely drool over. When you talk about secondary keys, you shouldn't just be talking about databases. You should immediately link it to evaluating algorithm efficiency. You should be talking about time complexity. You should be talking about search speeds. A secondary key creates an index that allows an algorithm to sort and retrieve data so much faster, which directly impacts the entire performance of the system. Linking database keys to algorithmic efficiency, that shows an incredible level of mastery.
Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously do it, because consider this an alarm bell for your revision. These three keys, primary, candidate, secondary, they interact constantly. You must tune in to how changing one key echoes throughout the rest of your architecture.
Section 3. The procedural framework. How do we apply this knowledge systematically, under pressure? Listen, top-scoring candidates absolutely do not wing it. They don't just stare at the paper and wait for inspiration. They follow a rigid, standardized sequence to decode command words and structure their answers. Let's walk through the exact 5 steps you need to use, every single time. Step 1. Deconstruct the question. What is the command word literally asking you to do? Is it evaluate? Is it describe? Those require totally different answers. Step 2. Extract relevant data. Pull the specific scenario details directly out of the prompt. Step 3. Select your analytical framework. Are you comparing similarities and differences? Are you using the Peel framework? Point, evidence, explanation, link to structure a paragraph? Step 4. Execute with clear notation. This is vital. Show your step-by-step decomposition clearly on the page. Step 5. Present with correct terminology. Use the exact words: primary key, candidate key, secondary key. Don't call it the main identifier. Call it the primary key. Following this framework ensures you provide logical, structured reasoning. It proves your data interpretation skills to the examiner, and it secures those method marks.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Stepping up from a B to an A-star requires you to internalize everything we're talking about today until it's second nature.
Section 4. The interactive workshop. Now it's time to put you on the spot and test your evaluative thinking. Okay, I want you to look closely at this data source. We are comparing algorithm trade-offs. You've got columns for strategy, time complexity, space complexity, and edge cases handling. Imagine you're on the clock. 60 seconds. Go. When an exam asks you to choose a primary key from a list of candidates or design a retrieval system using a secondary key, you aren't just picking what looks nice. You are essentially evaluating complex alternatives. Top-scoring candidates demonstrate their thinking by analyzing these exact trade-offs on the screen. Sure, a secondary key makes your time complexity amazing, searches are lightning fast, but what's the cost? Space complexity. You have to store that extra index. They acknowledge the limitations of a specific choice and justify their decisions with solid evidence. As you scan a table like this in an exam, your brain should be instantly practicing comparative analysis, identifying the similarities, calling out the differences, and drawing hard, evidence-based conclusions. Now let's play Find the Flaw. This comparison right here highlights the principal examiner's ultimate warning. It is the absolute biggest red flag they see when grading. On one side, we have the generic answer. This student just defines the keys theoretically without any context whatsoever. It's essentially copying and pasting the textbook onto the exam paper. A primary key is a unique identifier. Cool, 0 marks for application. On the other side, the context-specific answer links the key selection directly to the given business scenario using the Peel framework. If the exam question is about a hospital database, your answer must talk about patient IDs and ward numbers. You cannot just say attribute A and attribute B. The classic mistake, the sentence that loses you the mark, is the generic one. Always link every single point you make back to the specific scenario provided. Section 5. Top Examiner Pitfalls. Let's pull back the curtain and look directly at what the principal reports are saying.
There is a number you absolutely need to burn into your memory today. 3. There are 3 devastating mistakes, 3 primary warnings from the examiners that constantly, year after year, appear in the reports regarding database terminology. If you can avoid these 3 traps, your mark potential immediately shoots up. Let's break them down.
Pitfall number 1. Examiners report that students constantly confuse cause and effect in key selection. They completely misunderstand how changing a primary key causes a ripple effect that impacts the entire relational structure of the database. You change the anchor, the whole ship moves. Pitfall number 2. Students forget to check boundary conditions and edge cases. When you design algorithms or select data structures, rigorous testing isn't an afterthought. It's part of the procedural framework. You have to consider what happens at the extremes. What happens if 2 people have the exact same name and date of birth? That's an edge case. And pitfall number 3, which we just hammered home, but it's so incredibly important it needs repeating, providing generic answers not specific to the context given. The Cambridge Assessment Framework prioritizes analytical depth. You literally cannot achieve depth without applying it to the context.
So how on earth do we lock all of this complex theory, all these frameworks, into our heads under extreme exam pressure? Well, here is a really powerful memory hack straight from our subject specialists. Create your own mnemonic for database terminology using the first letters of key terms. Take primary, candidate, and secondary, PCS. Or take the steps of the procedural framework we talked about. Deconstruct, extract, select, execute, present. DESEP. Make up whatever silly phrase works for you. Creating a mnemonic allows you to rapidly recall the correct terminology and the structured steps when that timer is relentlessly counting down. It ensures your systematic processing doesn't just fall apart the minute you feel stressed. Section 6, the final system. Let's consolidate everything into one foolproof exam strategy.
Think of these 3 golden rules as your ultimate cheat sheet. Number 1, command word decoding. Before you write a single, solitary word, identify exactly what cognitive domain the question is targeting. Don't evaluate if it says describe. Number 2, procedural framework application. Specifically, the Peel framework. Make your point, provide evidence from the prompt, explain the computer science theory, and link it back to the scenario. Show your algorithmic thinking step by step. And number 3, the time management matrix. Don't panic and rush like Sam, and don't blindly overload your answer like Alex. Use your time strategically to build logical, structured reasoning, ensuring you evaluate those candidate key alternatives and check for those sneaky edge cases. Implement this system. Make your marks like a street artist, but with solid structure, and you are well on your way to that A-star.
Look, the data speaks for itself. Students who implement these computer science strategies see an average improvement of 2 great boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Practicing this level of analysis consistently is literally the only way to break through your grade ceiling. So as you review your database structures today, I want you to ask yourself a hard question. Are you just memorizing facts to barely pass a test? Or are you actually building the analytical architecture required to master complex systems? The keys are literally in your hands. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.